Okay, we're going to describe a new specimen that came into the Santa Cruz Museum. This is a vertebrate specimen. This is the bone here. The problem with this specimen was that the bone was encased in concreted sandstone with shells around it. It's called a storm deposit shell bed. And it was found loose on the beach, and so the species of these shells are really important for us in order to be able to tell what exact layer it came from along the beach here in Santa Cruz, what ancient layer of the Monterey Bay. So here we record all the species of clams. This is a cassia here, clam or snail. And this is before prepping it out, removing all the sand and shells. This is a leucoma. Here's what appears to be perhaps a solon. Here's a Mitrella gouldi. Here's a mycoma here, a leucoma here. And we record all of these species of shells so that we can match it potentially to the original layer it came from, and thus determine the potential age of this specimen. Here's another view of it with the encased concreted sandstone and shells. There's another Mitrella there. So we record all these species before we really get into the digging out of the bone, which is right here. There's a view of the setup. This is a Zoic brand T-Rex, it's called. That's the model. And we use this. It's basically a miniature jackhammer, and it removes all this concreted matrix around the bone. And here you can better see the bone itself. This was a high value specimen because it was the bone was complete and not just a fragment. This is a sandbag right here that we work on in order to properly support the specimen. And this is our air lines coming into this pneumatic scribe. Here's, once we got going, we could record all of the shells that were embedded inside the concreted sandstone. This is a naticid snail, a carnivorous snail. Here's another view a little bit further along. This is a Cryptomya californica alongside of a mycoma clam, and these are the scribe marks right here. Here it is a little bit further along yet, still. Some of this matrix has been removed from the bone, and we're working along here to get it scribed out and prepared. This particular specimen was also important because the bone itself looked a little unusual, unlike anything we'd seen before. Here it is a little bit further along. Now you can see these cracks here. These cracks are not cracks that formed recently. They're ancient cracks. And originally we had proposed that we could best prepare this specimen by putting it in a bath of acid, weak acid that would eat away at this sandstone. But it turned out because of these cracks, an acid bath would potentially break the specimen into a few fragments because the acid would attack the sediment in these cracks. So we ended up scribing the entire thing. There we are, a little bit further along. Here's a sped up view of the work. I wish it went this fast, but it's a very, very slow process. Altogether, the whole process of scribing this out took about 24 hours in total. And here it is in real time, showing a little bit further how slow the process is and how far we've come in removing these ancient concreted sediments here. Now it was important to make sure that we worked with a mask. We had a filter mask that we were using during this process. another thing to notice right here is, even though I have some juice, I wasn't opening it without cleaning it and making sure that the area was clean. Here it is a little bit further along, and showing the specimen and getting it prepared and supported. As I mentioned, it's really important to support the specimen um, as much as possible to prevent any breakage. Here it is, close to the final steps of the process, getting the last little details. This is a different scribe. This is called a velociraptor scribe, and it's very fine for really delicate work. The T-Rex is used for mass removal of hard matrix. Well, as to what this thing is, or was, that is, we had to consult the literature and colleagues for what this could potentially be. And our colleagues, Bobby Bosenecker, were able to tell us that this probably is closely related to an ancient walrus bone. And this ancient walrus had been named, and this is one of the paleontological papers that this specimen was described in. It's close to what we call Dusignathus. In fact, Dusignathus santacruzensis is what it most closely resembles, but not quite. It turned out to be a humerus, and here's a humerus of Dusignathus santacruzensis right here. And this is a mature specimen. It turned out, according to what Bobby says, to be what we think is a immature female because of the size and some of the shapes of it. This is a radius of Dusignathus santacruzensis. And again, this is from the famed paleontologists Charles Penning and Richard A. Tedford, 1977 publication. So it most closely resembles the humerus of this walrus right here. And here's the radius of that walrus. Immature, of course. Well, Dusignathus santacruzensis, of course, was named, this walrus was named after Santa Cruz. And it was named in 1927 by a famed paleontologist named Remington Kellogg in this paper here. And Remington Kellogg, of course, was one of the more famous paleontologists in the early parts of the last century. He took his PhD from Berkeley back in the early years of the last century, and he worked for a while after his paleo degree with the U.S. Biological Survey, I think for 8 years, and before he really dug in with his career in paleontology at the U.S. National Museum, Smithsonian Institution. He actually married one of his friends from Berkeley, and they had a house in Washington, D.C., and he worked on the West Coast quite a bit as well. And this species, Dusignathus santacruzensis, was named from a fossil specimen, skull and teeth and jaws, skull fragment, jaw fragments from out near Lighthouse Point in Santa Cruz in the cliffs, and fragmentary specimen, but enough to give it a name. And in between that time and now, we've found many more bones of this ancient extinct walrus here in Santa Cruz. Here's a picture of one of the bones of this walrus at UC Berkeley. And here's a radius, 2 radii, of an immature specimen of this extinct walrus found here in Santa Cruz. These are the same specimen here, and this is another specimen here found out on the west side. So the specimen ended up looking like this originally when it was being prepped up with some of the sandstone still on it here, and it ended up being very exciting for us, finding out that it was related to this ancient walrus. And here it is, of course, all prepped up. So you can see that it's quite magnificent because it's complete. It shows all the parts of this critter. This is the part of the humerus. The humerus, of course, is the upper arm bone. This is where it would hook into the scapula, the shoulder blade, and this down here is where it would hook into the radius and ulna, the lower parts of the flipper, the front flipper of this ancient creature from Monterey Bay. So that's the specimen, most recent specimen from the Santa Cruz Museum of Natural History that Pacific Paleontology has had the pleasure of working on and preparing and bringing back to light what this ancient creature potentially could have looked like. So, left humerus of a female immature Dusignathus santacruzensis potentially. It doesn't quite look completely like that, but that's the closest thing we have right now, according to the experts, Bobby Bosenegger. All right, that's all for now. More later. Signing out from Pacific Paleontology and the Santa Cruz Museum of Natural History.